Hi folks.
Knurling.
Parts on a CNC mill. So the backstory to this is we were hosting our first post-COVID hands-on CNC training class. It's awesome to be hosting our training classes again. We've actually got them in a new dedicated facility right next door to our current shop. And Adam Booth, if you don't know, Adam has an awesome channel, has a long history as a third-generation manual machinist, and he's coming over to the world of CNC. And so it was pretty cool to have the chance to spend time with him learning Fusion and then running CNC machines. What's fun is that when you get somebody from kind of an outside perspective, they ask better questions sometimes because they're not prejudiced by what we all know already. And Adam said, how could I knurl parts on the mill? And it's kind of a weird question because if you're familiar with lathe knurling, there's cut knurling, there's sort of form pressure knurling and so forth, but it's a turning operation. I said, you know what, Adam, let me chew on this and get back to you. And we figured it out. What we've got is a large thread pitch, multi-start thread that runs right hand and then comes back and runs left hand to create a fake or synthetic style knurling. This first example here is a gentle example. I'll show a steeper example to give you a comparison of the two options and show you guys how you can play with this to add this sort of a texture or feature to your parts. What's awesome though is the simulation is actually really good indicator of the kind of diamond pattern or the texture that you're left over with. We're using a Lakeshore Carbide 1/2-inch single profile thread mill to cut this feature. Happened to be the tool that I had on hand, actually already set up in the machine. Another example that should work would be any of these high-speed steel double angle chamfer cutters. This is an example from Mari Tool right here. The thought process that went on in my head for this was a threading operation should be able to work. So create a thread mill operation. We'll pick our Lakeshore tool and we'll click our surface, and you would adjust your thread pitch to accommodate whatever screw you're trying to thread mill. But we're not looking for a traditional screw thread, if you will, but we're looking for something that's really steep. So the first thing we need to do is really increase the thread pitch. I start off with 2 inches, and that immediately transforms from a traditional thread to something very unusual for any sort of a threading operation. But then what we need to do is take advantage of the Fusion multiple threads option, and I started out with 15 threads on this part. The stock that we have modeled up here is 1.5 inches in diameter, or about 38 millimeters. When I simulate this, I'm turning off the model visibility because I don't want to see the CAD model. I only want to see how the tool is cutting the stock. And at first, we don't get anything. And that's because the tool is actually just tangentially kissing the outside of our part. We need to program it to cut in a little bit. And that is controlled via the pitch diameter offset. It's a positive value that cuts into the part, so it's kind of an inverted number, if you will. And let's just say 30 thou. Click OK. And now if we simulate, you can see we start to get half of the knurling operation. Once you've got a value you like, right-click, duplicate this operation, and all that we have to do is edit that toolpath under the Passes tab, change our threading hand from right hand to left hand, and watch. It mirrors it from a right hand to a left hand, and now we have that cross-hatched pattern that we want to see. Do a quick simulation. I think that looks great, and it's super easy to do. It certainly takes longer than turning on a thread, but it's not super common to see threading, especially on CNC turning centers. And if you guys have followed the channel for a while, you'll know I'll do a lot of things to figure out how to turn a part on a mill. If you're looking for a different style knurl, play with some of the settings, but I was able to do this steeper version by just modifying the thread pitch from 2 inches up to 4 inches at 15 passes. Here's what the knurl looks like at 20 thread starts, and here it is at 25 passes. A couple of final kind of housekeeping notes. Something I'd love to see in Fusion 360 is the ability to use cam expressions. I think we're close. I think they've made progress on this, but rather than hard coding a number here, like 18, I'd really like to be able to have a value like you can over in the CAD side or an expression, and that way if we're doing things like this we can link the same number of threads or the depth across multiple cam operations and not have to go in to manually edit each one of them. And finally, there are a couple of speeds and feeds style settings here in terms of the number of step overs and the depth of those step overs. Those are really going to be specific to the style of cutting tool, the machine, the material, and so forth, but I would encourage you to take it easy, especially if you're new to using this style of tool. The nature of it being a triangle means every time you're increasing the depth of cut a little bit, you're cutting more along that triangle, so you're actually increasing the tool pressure quite a bit. So take it easy, especially when these often tend to be more expensive tools than your average end mill. Otherwise, folks, hope you learned something, hope you enjoyed, take care, see you soon.